All right, so the other day in section 1.2 we had some data, and from our data we drew what was called a scattergram. We're going to do that again today. So we're going to be given some data and we're going to draw a scattergram. Why would you draw a scattergram other than the teacher told you to? It's another form of the data, and what it does is when you look at a scattergram, you can look at the data and you can see, hey, does that data look like it falls into a line? Or does it look like it falls into some other shape? And what you generally want to do once you have data and once you have its graph, you want to find a model. A model is an equation that comes close to fitting the data. So the reason you want to draw the scattergram first is you want to look at the data and you want to make a decision. Looking at this data, does it look like a line? Or does it look like a parabola? Or does it look like there's all sorts of other kinds of functions, exponential, logarithmic, trigonometric, so on and so forth. For this course, we're primarily going to deal with two kinds of equations. We're going to deal with lines, which we'll do a lot of, and near the end of the course, we'll deal with something called parabolas, or quadratic functions. So that's going to be the big deal for us. We'll look at our data, and we'll decide, does it look like a line, or does it look like a parabola? For today, we're going to deal with lines. Why would you want to find an equation of the data? What would that be good for?
Pattern.
For what?
A pattern.
Right, you look at the data, that gives you a pattern. The equation is another way to look at the pattern, and then what are you going to do with that equation?
Solve.
Solve for what? We like to solve equations.
Solve for X.
Okay. Why would you want to solve for X?
Give me the answer.
To get an answer, yeah, what you really want to do, we use the model or the equation to make predictions. Okay, and this is very, very common. People gather data, and then they try to use the data to try to make a prediction about what's going to happen in the future. For example, if you buy and sell stocks, what would you want to know? Whether it's going to crash or whether it's going to go up. If it's going to crash, you want to sell it right now. If it's going to go up, you want to buy it right now. You want it to increase. So that's the sort of thing that we're going to be looking at. We won't be looking specifically at stock prices, but that's what we're going to be looking at. We'll have data. We'll use the data to try to make a prediction. Okay, so the first kind of thing we're going to do today is just practice reading graphs. So here's a graph. I gave you the graph of a nice straight line. And part A says, find y when x is -2. How do you do that?
You would plug -2.
Uh-huh.
You go to -2 and over to -2 and go up until you intersect with the line.
All right, so I start here, and I go to x equals -2. That's this way, right?
And then you go up and where the line intersects.
It looks like y would be not -2, but rather
2.
+2. So that one looks like y equals 2. Okay. Find y when x equals 4. Kind of the same deal, right? We start at the origin. We go to where x is 4. 1, 2, 3, 4. We go down until we hit the line. Looks like y is -1. All right, and then they give us a couple problems that are the opposite. Now they're giving us the y numbers, and they want us to find the x numbers. So what do I do when it tells me y is -2? I go down to -2, so I start at the origin, I go down to -2, I come across till we hit,
6.
looks like x equals 6. Very good. And finally, when y is 4, let's see, here's up to 4, I go across, I agree, looks like -6. X equals -6. All right, then the last two questions are a little bit different. It asks, what is the x-intercept? What do we mean by x-intercept?
Crossing the
Where we cross the x-axis. So where does this graph cross the x-axis?
2, 0.
All right, when you say 2, you really mean x equals 2. And then what's the y value? 0. Where it hits the axis is really a point. It has an x number and a y number. So when I ask you where is the x-intercept, you should really give me a point. You should give me an x value and a y value. And we decided it was what? 2, 0. So the x-intercept should be written that way. It should be written as a point. X is 2, y is 0. Conversely, where is the y-intercept?
0, 1.
0, 1. Right there. That's where we cross the y-axis. Again, watch the order on your points. It's really easy here to write 0, 2, and really easy on this one to write 1, 0. Make sure you get them in the right order. X number always first, y number always second. Okay, problem number 2 says, water is pumped out of a flooded basement. Let V be the volume of water in thousands of gallons that remains in the basement T hours after water began to be pumped. And it gives you a graph there of what happened. So on your x-axis you have time in hours, and on your y-axis you have the number of gallons in thousands. Part A says, how much water is in the basement after 2 hours of pumping? 18,000, and how did you get 18,000?
I just went over to 2 on the scattergram and went up until it hit the line.
Perfect. So it gave you 2 hours. So in this case, it's giving you an x number, isn't it? Hours are x values here. So we went over to 2 hours. We went up. And you've got to make a little bit of approximation. It's hard to tell exactly, but I think 18,000 would be a very good guess. I think 18,000 gallons. Would be a very good guess. Is that a lot of water?
Yeah.
Yes. Is that unbelievable that you would have 18,000 gallons of water in your basement?
Not really.
A couple years ago, one of our faculty members here lives over near Binghamton. And a couple years ago, they had flooding. He was able to borrow a pump from the fire department that pumped 500 gallons of water a minute. And that kept his basement from flooding anymore. So he was pumping out 500 gallons a minute just to keep the water level the same. He wasn't gaining anything. So is 18,000 gallons unreasonable? Unfortunately, no. That's an awful lot of water. But you could have that much water in your basement. It's not an unbelievable number. It seems unbelievable, but it really isn't. Okay, and then it asks, part B. After how many hours of pumping will 5,000 gallons remain in the basement?
We got 4 hours and like 20 minutes.
Right, so this time, what's it giving me? It's giving me a Y number, isn't it? 5,000 gallons. So that's the first thing you need to recognize when it gives you a number. Is it giving you an X number or a Y number? 5,000 gallons. Gallons are the Y values. So I go to 5 on the Y axis, and I come across, and I agree, it looks like it's just a little bit past 4 hours. So again, you're going to estimate. I heard somebody say 4 hours and 20 minutes. Is that a reasonable estimate? Yeah. If I were to write 4 hours and 15 minutes, would that be a reasonable estimate? Yeah. If I wrote 4.5 hours, would that be reasonable?
Oh, no.
Probably not. It doesn't quite look like 4.5, does it? Yes.
Now I know online it gives you like a few point difference. Now if you're off, say 3 points, and they wanted you to do within 2, and you get it wrong on the quiz, would you, if we write you a little note, would you accept?
Absolutely. So if you have an issue like that on the quiz, where you look at this and you say, that to me looks like 4 hours and 10 minutes, and it marked it wrong, that said the right answer is 4 hours and 15 minutes, send me an email, tell me which quiz you're working on, which problem number it was, and I can go in and I can look at it and I can change the grade. Absolutely. If you give me a reasonable answer, I will give you correct. The computer, sometimes problems like that are set up with a little bit of wiggle room. Sometimes they're not, and it's not terribly consistent sometimes. So anytime you have an issue like that with a homework or a quiz, send me an email. I can go in and I can see exactly what you've done, and I can change it. So we're going to say, what do we want to say? 4 hours and 20 minutes? Okay. Very good. What is the v-intercept? 30,000. Again, an intercept though is a point, and you should give me an x number and a y number.
0, 30.
So you should write it as 0, 30. The v-intercept, this is our v-axis this time. I agree, it looks like it's right at 30, so 0, 30. What does it mean in the context of this problem?
The maximum amount of water goes in the basement.
That would be one good way to say it, the maximum amount of water.
How much water you started with?
It's how much water there was in the basement before you turned on the pump, would be what I would prefer. But if you gave me that answer, it was the maximum amount of water, that would be okay. My answer would be there were 30,000 gallons of water when the pump was started. And again, that seems like an ungodly amount of water, but it's not unbelievable. Okay, part D. What is the t-intercept?
0.
50. So the t-intercept, this is our t-axis, it's time. Where do we hit the axis? Right there at 5. So 5, 0. And what does it mean in the context of this problem?
5 hours to count
5
all the water.
hours, all the water's gone.
That's right. So this is 5 hours, 0 gallons of water left. So in 5 hours, all the water gets pumped out. The water is pumped out in 5 hours. Questions on that? Okay then, moving right ahead to number 3. Let S be a person's salary in thousands of dollars after he has worked T years at a company. Data is given in the table below. Create a scattergram of the data, then draw a linear model. Okay, so first we want to draw a graph. Which value goes on the x-axis,
So T's.
and which one goes on the y-axis? T goes on x? How do you know T is the x numbers?
You know what's independent variable, but
Time is almost always the independent variable. If I give you a table, it's always very, very easy to tell which one is independent. The one that comes first is always the independent. The one that comes second is always the
dependent.
dependent. So I should put time on my x-axis. And how do I want to label my little tick marks? Do I want to go 1, 2, 3, 4, 5?
You want to do one each?
Better go every other 2, 2, 4, 6, 8, 10.
How about just 2, 4, 6, 8, 10? Is that too tight, you think?
Yeah,
Too
okay.
Too tight? Okay, so we're going to go by ones then. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 if you want. Again, you don't have to label every single one of them. You don't have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You just label enough of them so that somebody can see the pattern. Y-axis, we're going to have salary. Do I want to go 1, 2, 3, 4, 5 on the y-axis?
By 4s.
Go by 4s?
Yeah.
So let's see, that would take me 4, 8, 12, 16, 20, 24, 28, 32, 36. That'll get me up enough. Okay? So that's 8, 12, 16, 20, 24, 28, 32. Correct? 8, 9, 10, 24,
So we
30.
could do 1 by 5s instead of 4s.
Sure, I think going by 5s would work. Yeah. Why did you like 4s?
Because it led exactly to 40 and is Closest one to make it all in.
because the 4s hit exactly 20, and then it hits exactly the 24 and exactly the 28, so we're not having to kind of estimate in between the lines. But yeah, if you went 5, 10, 15, 20, that would work. When you draw your graph, you would just have to estimate a little bit. Be fine. Okay, draw my points now. 0, 20 is right there. 2, 24. 4, 28. 6, 32. And finally 8 and 36. Looking at my data, does it look reasonable to use a line to estimate my data?
Sure.
Looks very reasonable, doesn't it? Okay, so that's what it says to do. It says create a scattergram of the data, then draw a linear model. So what does it mean by draw a linear model?
Get a line graph.
Make it a line graph. So I'm going to take my ruler, and I'm going to play a game of connect the dots. And they should come really close to connecting. In fact, if I'd have done this one exactly, they would have connected perfectly. But as you can see, it's very close. So that's what they mean when they say draw a model. Take your ruler and play a game of connect the dots.
Now, technically this would be a line segment because you can't go backwards from 0, right?
Yes, and you're getting into what we call domain. Domain means what numbers can I really use for t? And you're absolutely right. I probably should have stopped right here, because can t be negative? Can I work for negative 2 years? No. So technically, I think you're right. I should have drawn a line segment, but in the book they draw the full lines, so that's why I did it too. We'll talk more about that later. What are reasonable numbers to use for t? What are reasonable numbers to use for s? Those are things called domain and range. Okay, so now what they want us to do is they want us to look at the graph and estimate the person's salary after he has worked at the company for 5 years. What am I going to do there? Go to 5 on the x or the y? On the x, because time is x. I go up, 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 up.
30.
Well, I think
Yeah, I got
30,
30.
29. I think either of those would be reasonable. I think I heard 30 first, so I'm going to go with 30,000. Okay. Estimate when the person's salary was 34,000.
70.
Well, that seems reasonable because it was 32 at year 6 and 36 at year 8. So year 7 certainly seems reasonable. It's halfway in between. And that makes sense on the graph, right? We would go to 34 would be here. Come across. It does look like it's about year 7. Year 7. Okay. What is the S-intercept?
0, 0.
It would be 0, 20. It's right there. It's right where we cross the axis. What does it mean in the context of this problem?
Starting salary was 20,000.
Starting salary was $20,000. Questions on that?